Hi everyone, in this video we are going to learn about closures. Even though we used closures before, with this lesson we are going to learn them in more depth and we are going to see how we can use this in many various use cases. So closures are like the arrow functions or the lambda functions in other programming languages, and we use them in Rust for the tasks that we don't even want to create a new function for it, or we can provide these closures as parameters into functions. So before further ado, let's go ahead and see how we use closures. To define a closure, first I'm going to create a variable. I'm going to call this my closure, and here I have two straight lines. These lines that indicate I'm getting some parameter here. Since I'm not going to use any parameters, I'm going to leave this empty for the time being. And here I will say println, and let's say defining closures. So this is the section for my parameters, and this is my closure body. And to use this closure, I'm going to say my closure. Let's say cargo build first here, then cargo run as we are used to. As you can see, we got defining closures. So as we can see, they work like functions, but we are defining them in a different way. And through this lesson, we are going to see why we are defining them this way and what are the different use cases. But to give a general understanding on the syntax, this will be the part where we are going to use the parameters, and this part will be our closure body to be more precise. And once we want to use the closures, we can use them as the functions here. So let's create another closure. This one I will say even numbers. So what this closure will do is it's going to decide if the given number is even or not. For that, I'm going to have a parameter here x, and the type of the x will be i32. Next, I'm going to say the remainder of the x divided by 2 should be 0. If it's 0, this is going to be right. If not, this is going to be false, and this way we can understand whether our number is even or not. Now let's try this. I will say even numbers, and let's give 4 here, and I will say even numbers, let's say 5 here. But as you can see, even though we are calling this function, nothing is going to happen because the remainder is 0 or not, the number is even or not, but we are not returning any values. For that reason, I'm going to say here bool, which indicates that my closure will return a boolean. And after indicating the return type, I need to use parentheses for the body. And that way we have a fully functional closure. This closure takes a parameter which is x and the type is i32, and it returns a boolean, and this is the body of the closure. So once we use this with even numbers 4, we are expecting to be true, and with the even numbers 5, we are expecting to be false. So let's get our variables. I will say even, and for this one I will say out, and let's print these values. I will say is the first number an even number, and we will say even here. I'm going to say out here and second. So let's run and see if they work. This should be also even, since it's an odd number, it's not an even number. Yes, now the first one is true and the second one is false, and that's the basic syntax of the closures. Now let's create an example which we created before. For that one, I'm going to create my vector, and let's call this vector numbers. Inside this vector, I will have 1, 2, 3, 4, and 5. If you watched the previous lessons, I'm pretty sure that you are used to this vector. And what we are going to do is we are going to filter this vector, and we are going to use closures to do this. For that, I'm going to say that even numbers equals numbers dot iter. So now we have an iterator. So we actually talk about this part on the iterators, but if you didn't see them, basically what we are doing here is we are taking this numbers vector and we are converting this to an iterator which we can iterate through in it. And then I'm going to say filter, and this is a function which is going to filter our vector here, and depending on the function we are providing here, actually closure we are providing here, we will be getting numbers which are even. So let's define our closure. Our parameter will be x, and then we will say x divided by 2, and if the remainder is 0, we are going to call like that. So let's see what's happening here. And also let's see what's wrong. Yes, we also need to annotate this type. It's going to be a vector of I32. So let's see what's happening here. We are converting our vector to an iterator here, and after that we have a function filter. But this filter function takes a closure as the parameter. So whatever we define in our closure, this code is going to filter our vector based on this closure. So we use this closure and we solve the syntax. We should be familiar with the syntax by now. And this syntax says that I have an x and I'm dividing x by 2, and actually it's a modulus operation which gives us the remainder of a division. If this remainder is 0, then we are going to collect this item, meaning that we are going to put this item to our even numbers vector, which consists of I32s like our vector here. Now let's print out this and see if it works. Even numbers are, I'm going to use debug here because I want to work with a vector. Well, let's print out this vector. Now as you can see, we got 2 and 4, and this is another way to create our even numbers instead of creating a function, putting this vector as the parameter and iterating through this vector once the item is divided by 2, if it's 0 or not, and doing this for all these vectors, even though it's not a huge task, but it's just a more time consuming task. So if you can see, we have basically one line here. To have the same functionality, if we have another function, let's say is even, this is the name of our function, and we have one parameter, and this will be a vector of I32. And as a result, we are also going to return vector of I32. Inside this function, I'm going to create a new vector so that I can return it. Even numbers vector. And let's say vec new here. Now I got my vector. I need to iterate through this parameter numbers that I got. For that, I'm going to say number in numbers. Once we divide it by 2, if the remainder is 0 or not. So let's try this. I'm going to say if number modulus 2 equals 0, then I'm going to say even numbers that vector that push number. Okay, it's expecting a return type from us since we haven't returned anything yet. It's complaining. And down here, I'm going to return my even numbers vector. And we also need to say mutable here. Since we are altering this vector, we need to specify that it's mutable in the beginning. So this function gives us the same functionality as we did here. But as you can see, this is a much simpler way of doing this. So closures are generally better for tasks like this. And as we use the closures more, we are going to get used to where to use closures and where to use functions. Now, before moving forward, let's talk a little about the types of closures that we can have. First one is FnOnce. So this trait represents closures that can be called exactly once. They may move, consume values from their environment. It's like a one-party invitation. You use it and it's gone. We saw this before. Once we use this into underscore iter function, then what we were doing is we were actually consuming our vector, because after this point we cannot use this vector again, and we talk about this in the iterator videos. Next we have FnMut. So it's pretty self-explaining. This trait is for closures that can be called multiple times and can mutate values from their environment. It's like having a key to the house. You can enter as many times as you want and you are allowed to move the furniture. So this FnMut is specifically for mutable ones, and as we can see, it says that can mutate values from their environment. So this is another important aspect of closures. With functions, we cannot interact with our environment. So functions are more closed. With the closures, what we can do is we can actually interact with our environment, so we can catch many things as parameters like we did here. So this X here corresponds to every item that we have in our vector, which we transform to an iteration here. And finally, we have fn. This trait is for closures that can be called multiple times without mutating their environment. It's like being a ghost. You can pass through the house as much as you want, but you can't change anything. So these are the three different ways to have closures, and we are going to use this FnOnce in our following example. In this example, we are going to simulate data downloading session. So what we can do with the closures, as we talked, we can use them as callback functions. So callback function is a function that we are providing to another function as a parameter. So by providing our closure as a parameter to our download function, what we can do is we can get the data that we want to download, and after getting that data, we can directly use that data in our closure, so we can chain them together. So let's see the example. First, I'm going to clean here and define my function here. Let's say download data. In this function, we are not actually going to download the data, but we are just going to act like we are doing it. For that, as the URL that we will be reaching, we will have a parameter called URL and also a string reference here. For the second one, we are going to call this callback, and the type will be implement function once, and inside this a string reference. So let's see what we created as the parameter. To give closures as a parameter, we need to specify their type. As we talked before, using function once, we are indicating that we are going to use this once. And this implement meaning that we are actually using a closure, and here with this string reference, we are saying that we are going to use this string reference as the parameter for our closure. And this string reference, we will be getting this from our function. And now let's see how it works. Before moving on with the function, let's first define our closure. For that, I will say let print data, and we are going to have one parameter called data, which is a string reference. And here in the body, we are going to simply say receive data and the data that we have. Now we have our closure here that we can use as the callback function. Now we are going to simulate a data download. To simulate it, first let's say getting data from URL. Now this is the part that we are getting data. Next, we are going to simulate a delay. In general, we would wait to retrieve any data from the web. For that, we are going to simulate this process. So let me paste it here and explain to you guys. So we have our standard library, and under the standard library, we have the thread and sleep. So with this sleep, we are telling our code to wait, and duration is 1 second. We didn't import or use any of these libraries. It looks like very long line and a lot of semicolons, but what we are doing basically is that we are saying, okay, we want to sleep and for this much of a time. To import these, we had to use this site and this site here, because again, we didn't import this, but it's just a very basic functionality. We are going to stop doing anything for 1 second. Next, let's simulate some data input. For that, I'm going to say let data equals, and here I will say some data from our URL. So with the format, I'm actually not printing this, but I'm getting this value here, some data from our parameter URL here. So this will be our string that we put in our data variable here. So finally, here I'm going to call our callback function, which will be our print data function actually, and I'm going to provide our data here. Now let's create an example in the main. For that, call our download data function, and as the URL, I will say Patika.dev, and for the callback, we are actually going to provide our print data closure. So let's see if it works. I'm constantly saying let's see if it works in our lessons, but 90% of the time there's some small mistake that I have made, or maybe you have made. But don't worry about it, because Rust compiler won't let us to move on with our mistakes. Now, as you can see, getting data from Patika.dev, and next we got the message receive data, some data from Patika.dev. The idea is we will be able to use our closure here as the callback function for our download data function. So we actually chained them together. Through our data retrieval, we will be able to pass this to our closure, and we could take this closure as a parameter here instead of calling another function, because if we were to call another function here, that means that we can only use this function in conjunction with that function. But once we get this closure as the parameter, then it means that we can get many different closures. There are many different use cases for this function. So that's it, folks. That's the basic usage of the closures. As we talked, it has many use cases. So the more we use these closures, it's going to feel much more easier for us to work with closures, and then we are going to see the full power of them. This closure lesson is an advanced lesson, but we said this is an advanced because you can code a great deal without using closures in Rust. And we created our advanced classes based on you can code without knowing these topics, and you just learn them later. So we can do great things without using closures in Rust, but like our other advanced topics like lifetime, it's very crucial to know this kind of a behavior and the functionalities of Rust to create a real world product, because Rust is utilized based on these advanced topics and usage too. So we can achieve great things. You can learn and code in Rust without knowing our advanced topics that we discuss in our entire course. But it's very beneficial to use these topics like the lifetimes, like the closures and trait objects with our projects, so that we can understand how to use them. And after we got used to these advanced topics, then we can see that how better programmer we are, how better our code is, and how more fun actually it is with using advanced features in Rust. So thank you very much for this video, and I'm going to see you on the next one where we talk about the modules.